And so we begin. Chapter 1, Data and Statistics. Is changing over time. We're going to talk about that just a little bit. Then we'll quickly run through some applications in business and economics. We're going to spend most of the time talking about data and the way that you can break it down. Just a little bit about different sources of data. Descriptive statistics, that's changing the way that people look at that as a more encompassing term. Statistical inference, we're going to explain a little bit about that. We really won't get to that until the second part of the course. Microsoft Excel is the statistical tool that we're going to be using to help us do a lot of these procedures much more quickly. Is the process by which you take a large group of individuals and you try to infer something about them based upon a smaller group. The smaller group is referred to as the sample. The word parameters refers to the calculations that you do for the entire group. The word statistics, what it historically referred to, was the calculations that you would do for the smaller group. And you'd want to take a random sample so that you could get probability to work for you. But now the word statistics is expanded to talk about collecting and presenting the information in addition to just the calculations for the smaller group. You can calculate averages, medians, different measures depending upon what type of data that you have. But nowadays statistics refers to a much bigger set of concepts. It's the art and the science of gathering that data, analyzing it, presenting it, and coming up with meaningful interpretations. Business and economics, you can make use of statistics. In accounting, the auditing process is a place where they make use of it. In economics, there's always another forecast that needs to be done. In finance, they look at the past performance of stocks and bonds so that they can make recommendations to their customers regarding their investments. They can take information that's pretty much up to the minute in terms of what's selling, but they also use it in testing things. When they come up with new products or new ideas, they use test markets, which is essentially a sample, to see whether or not they want to market it to their entire set of customers. Production, they make use of statistical quality control to see whether or not the production process is proceeding as it's supposed to. In information systems, you can analyze the performance of your computer networks. This slide shows a number of different definitions. These are concepts with which you need to be familiar to understand the procedures that we're going to get into later on in this course. As an example of this, I'm going to use the population of students at Middle Tennessee State University. And let's say that we're doing a study on obesity, so we're interested in their weight. One of the items of data that you could collect regarding the students would be their weights. All of the data that you collect for a particular study is called the data set. The elements in a study of this type would be the students themselves. We're collecting data on the students. Weight is just one of the variables that we could come up with. We could also come up with the grade point average for a particular student. But when you look at all the different sets of measurements for a particular student, that would be referred to as an observation. And you can come up with the total number of the data values in your data set by multiplying the number of elements, in this case the number of students, by the number of variables, the number of different characteristics that we're collecting for each one of those students. Now let's take a few moments and talk a little bit about data. There's numerical data, which is referred to as quantitative, and then there's categorical data that's commonly referred to as qualitative. When you have numbers, you can break it down as being either discrete or being continuous. Discrete items, generally, you look at that as something that you count Whereas continuous numerical items, you look at it something that you can measure. Then in addition to whether it's quantitative or qualitative, the other words are numerical and categorical, you have something referred to as the scale of measurement. It runs from the lowest level, which is nominal, to the highest level, which is ratio. Now in general, you can look at nominal and ordinal level data as being qualitative or categorical. You can also look at interval and ratio level data as being quantitative. But the highest level is ratio, when ratios have meaning. Interval is when the difference between two numerical values is meaningful. Down at the lower end of the spectrum, nominal, you just have categories. But if there's a well-defined order between the categories, then you get up to an ordinal level. Now, one way to distinguish between ordinal and interval is if you look at two values and you say, well, this value is larger than that one, then that's ordinal. Do you know how much bigger it is? How much larger it is? You have to have that well-defined unit in order to get up to interval. Arithmetic calculations, you can do those with interval level data. But with ordinal, you're looking at kind of the position. If something's smaller or something's larger, you can talk about things like that if it's ordinal. But nominal and ordinal, primarily, you're kind of limited in what you can do with that type of data. These concepts are explored further in the following slides. The different scales of measurement, the nominal, ordinal, interval, and ratio, determines to a large extent what type of analysis that you can do. When you have data at a nominal level, all you really have is category. You can have a label for that category, you can have a name for that category. You could also put a numeric code in there. The example that's given here is the way that students are classified. Are they enrolled as business majors, humanities majors, education majors, and so on. But you could put a numeric code in there and say that 1 is for business, 2 is for humanities, 3 is for education, and things like that. But it's just a label or a name. You've achieved a higher level of data when you get up to ordinal. You still have categories, but if there's some concept of order that's well defined, you can have a label, you can have a name, but you can also replace that with a numeric code. The example that's given here is the classification of a student at a university. A person could be a freshman, a sophomore, a junior, or a senior. Seniors are going to have collected more semester hours than a junior, so in that sense they're more. Sophomores don't have as many hours as a junior, so in that sense they're less. But there's an order among the different categories, and that's what makes it ordinal. Now the interval level is higher than the ordinal level. So the interval, you automatically inherit that property of order. But to get up to interval, the difference between two values, and they've got to be numbers, the difference between two numerical values has to be well defined. Now here are the examples given for an SAT score. One person has a SAT score of 1985, another person has an SAT score of 1880. The difference between those is a well-defined unit. In the previous example about the different classification levels, person could be a freshman, person could be a sophomore. Well, I know a sophomore has more semester hours than the freshman does, but I don't know how many more. I can't come up with a well-defined difference. It's more, but how many more? Now ratio level data is up at the top. These types of data values, ratios have meaning. This item is twice as much as that. This item's 1.5 times what this other one is. You're dealing with numbers. Distance, height, weight, time, they all pretty much make use of the ratio scale. The classic example of something that's not ratio, it is interval, but it's not ratio, would be temperature measured in degrees Fahrenheit or temperature measured in degrees Celsius. In those instances, you can have negative values. When you have ratio level data, you have a 0, but the 0 has to indicate that that's it. That's as far as you go. There's not anything there to measure. There's not anything there to count. When you deal with temperature, you can go below 0. You can go above 0. And ratios really don't make sense when you allow positives and negatives. But that 0 value is kind of really the key characteristic of that ratio level data. You have to have that true 0. The example given on this slide for ratio level data is the number of credit hours earned. Somebody can earn twice as many credit hours as somebody else, but 0 is pretty much the limit. You don't usually think about somebody earning a negative number of credit hours, but you have to have that true 0 to have ratio level data. Data can be categorical or data can be quantitative. Now, another commonly used word for quantitative is numerical. Quantitative data and numerical data, it's the same thing. But what type of analysis you can use on it, it depends on whether it's categorical or whether it's quantitative. The arithmetic calculations are pretty much limited to stuff that's numerical. Categorical data is also referred to as qualitative. You have a label or a name that's used to identify the different elements. Now, it can be nominal level or it can be ordinal level. You can take the label or the name and substitute a number for it, but that doesn't make it numerical. You're limited in what you can do with this sort of data. You can figure out what the proportion is in a particular category. You can convert that to a percentage. If you have ordinal level data, sometimes you can come up with a median type of calculation. Half the values are less than or equal to this particular category. Half the values are greater than or equal to that particular category. But you can't really do things like averages or standard deviations with this type of data. Now, with quantitative data, there's a lot more that you can do with it. If it's quantitative, if you're dealing with numbers, it might be discrete or it might be continuous. Discrete is usually counting. How many of this do you have? Continuous is measuring, but you want to look at it from a theoretical perspective. If you had the necessary instrumentation, could you measure this finer and finer and finer? If you have something that's discrete, you're going to get to a point to where it's either this value or it's that value. It's not possible to have a value in between. But you're always going to have numbers if you're dealing with something that's quantitative. And most of your arithmetic calculations are going to be meaningful for that type of data. This discussion about data began with a combination of a couple of diagrams, categorical, quantitative, and then the different levels of measurement. This is just another organization of this as a hierarchy. You can take data in general and break it down as to being categorical or quantitative. Quantitative, another name for that is just numerical. You're going to have numbers. But the categorical part, you have a label or you have a name, which is a non-numeric form. But you can always use numeric labels in place of those names. But when you have a categorical entity, it's going to be nominal or ordinal. It doesn't make any difference whether you put a number on it as a label or whether you have a word or a text string as a label. It's still going to be nominal or it's going to be ordinal. The numeric parts, when you actually have numbers that mean something as numbers, it's going to be interval or it's going to be ratio. The ratio, you have to have the true 0. Now, we're not quite finished with talking about data. There's cross-sectional data and there's time series data. Cross-sectional data is data that's collected at either the same point in time or almost the same point in time. And you can analyze that differently than when you have time series data. Time series data is data that's collected over time periods. The example that's given is the number of building permits issued in a particular county in Ohio in the last 36 months. That would be a monthly time series. An example of something that would be a daily time series would be weather related. The temperature. What was the high temperature in Murfreesboro on a particular day? What was the low temperature in Murfreesboro on a particular day? And you can keep up with that information on a daily basis. You can see what happened in the past. You can see what the trends are. Overall, are the temperatures going up? Overall, are the building permits going up? And one of the major uses of time series analysis is to forecast for future periods. It used to be that when you'd see the word statistics, you were talking about summary measures that were calculated for a sample. But that's changed. Now we use the word descriptive statistics together to talk about something that's in a much larger setting. When you try to summarize and present information to where it's easy to understand, you could take a sample of data, and let's say that you had 50 values in that data set. Just looking at 50 numbers isn't really going to be that helpful to understand what it means. You can take that set of 50 data values and present it in a table. You can present that in a graphical form. You can calculate summary measures, but all of these items are referred to nowadays as descriptive statistics. This slide has a very brief description of a problem at Hudson Auto Repair. They have the cost of parts for 50 engine tune-ups. It's rounded to the nearest dollar. Now these are not all of the tune-up cost. This is just for a sample of 50. But just looking at the 50 numbers, you really can't get a lot of information out of it. If they were sorted, you could get a lot more information out of it. But there are other things that you can do to summarize this so that it's more descriptive. This slide shows the presentation of the data, the 50 values, as a frequency distribution and also as a percentage distribution. There were two values that were between $50 and $59. There were 13 values that were between $60 and $69. As you can see here, there was 29 values that were between $60 and $79. And if you add up the percentages, that's almost 60%, it's about 58%. But the majority of them were between $60 and $79. Whereas the frequency and the percentage displays on the previous slide were tabular presentations, this histogram is a graphical presentation. It shows the same information about the frequencies, but it shows it in a visual form as opposed to just having the numbers in the table. Now we're getting close to the end of this presentation for Chapter 1 on data and statistics. We started out with this little example with the 50 values. Then we formed the frequency distribution and the percentage distribution, which is a tabular display. Next, graphically, it was depicted with what's called a histogram. But in addition to displaying information in tabular forms and graphical forms, you can also calculate certain descriptive measures. The most common by far is the average or the mean of a set of data. It's a point of central tendency. We're going to look at others. We're going to look at the median. We're going to look at the mode. But the average on this little example, or the mean for this sample of 50, was approximately $79. At the beginning of this presentation on Chapter 1, we looked at the concept of statistical inference. We could take this little example about the Hudson Auto Repair and think about all the records as being the population. We took a sample of 50. Now, based upon that sample of 50, we came up with a value for the mean. It's possible to take that figure and then other things that we calculate from the sample, other descriptive measures, and come up with an estimate for what the value would be for the population, and that's referred to as a parameter. A census is when you look at all the members of the population and you come up and you calculate parameters and there's no error in it. But when you collect data for a sample, a lot of times you can do that with what's called a survey. This diagram illustrates the process for the little example. We don't know what the average cost is for all the parts, so we take a sample of 50. We use it to figure up a sample statistic value, and then you can use that, and we'll get into this when we get into Chapter 8, to come up with what's called a confidence interval estimate for that population value, that parameter. This concludes the material presentation for Chapter 1. Chapter 2, we're going to get more into presenting data in graphical forms and tabular forms for the different types, for categorical data and then the quantitative data, the numerical data. In Chapter 3, we're going to get into more of the calculation aspect of this, calculating summary measures. Remember the recommended completion date for the Chapter 1 homework task. There are 2 practice tasks and there's a quiz, is July the 5th.